Hello and welcome back to another video. In this problem, we're told that the Heaviside function defined in exercise 59, which we have down here, h of t is equal to 0 if t is less than 0 and 1 if t is greater than or equal to 0, can also be used to define the ramp function y is equal to ct h of t, which represents a gradual increase in voltage or current in a circuit. So the original function h of t goes from 0 to 1 and then it stays at 1. This new function y, as t increases, right, the value increases as well. And it increases along with it. So if t is 10, this is 10 times 1, which is 10 times c. If t is 100, it's 100c. T is 200, it's 200c, and so on. So it's increasing consistently. So here, sketch the graph of this function where c is just equal to 0. So we have in the xy plane here, this function y, and before the t is equal to 0 point, t is less than 0, h is equal to 0, so no matter what t is equal to, anything times 0 is just 0. So we have, in a similar way to the previous problem, this continuous function at 0. However, what changes is in the positive direction. So if we're multiplying h of t, which is 1, by t, then we can say that y is equal to t. Why? Well, it's y is equal to t times 1 for this particular interval. So t times 1 is just t. In the same way, we can think about it, y is equal to t times 0 for this side, therefore y is just equal to 0, which gives us this graph. So if y is equal to t, we can just draw that function in roughly like that. And this is the graph of the ramp function for c is equal to 0. Or sorry, c is equal to 1, which just gives you this. For part B, we're asked to sketch the graph of the voltage v of t in a circuit if the switch is turned on at time t is equal to 0 and the voltage is gradually increased to 120 volts over a 60-second time interval. And we're asked to write a formula v of t in terms of h of t for t is less than or equal to 60. So let's sketch this graph first. In a similar thing, we are starting at 0, so before 0 there's no voltage. So that stays the same. And then the voltage is gradually increased to 120 volts over a 60-second time interval. So this is a little bit different on this side. The increase is greater. Here, y is equal to t times h of t. Like we said, this is y of t on this side. So for 60 seconds in, we'd be at 60. Y value, the voltage would be 60. However, instead it's twice as much. It's going all the way up to 120. So the slope is twice as much. Therefore, we can think of this as not only in terms of the original function, but we have to do a transformation to it. What do we actually do? Well, if all of the y values of this function are going to be twice as high as they are in this function, right? For example, instead of 60-60, it's 60-120. This is a vertical stretch by a factor of 2. Therefore, v of t is equal to, using how we know to input transformations based off of an original variable, this is 2h of t, right? All the values here are being multiplied by 2, which doesn't do anything on this side because 0 times 2 is just 0. But here it increases twice as fast, which gets you to 120 volts in 60 seconds instead of 60. Next, we have to sketch the graph of the voltage v of t in a circuit if the switch is turned on at t is equal to 0 and the voltage is gradually increased to 100 volts over a period of 25 seconds. So here, it's increasing even faster, right? Instead of 25 and 25, it's 125, so it's 4 times more. And again, this is still the same. And by the way, I should fill this circle in, right? Because it's less than from this side, greater than from this side, therefore it includes 0 at this point where they meet. But anyways, we have this function, which is even steeper because it's being stretched by a factor of 4. to get it from 25 to 100 at this time. Therefore, v of t is equal to 4 h of t. However, we have a problem here. We are describing a specific increase in voltage, right? It is 100 volts over a period of 25 seconds. However, it then stops, right? It remains constant at the value of 100 all the way to t is equal to 32, which is our ending point. Therefore, we have to have a different function for t is greater than 25. So what we have here is a piecewise function. V of t is equal to 4 h of t for t is less than or equal to 25 and t is greater than 0. However, t is equal to 100 at 25 all the way to 32. So how do we do this in terms of h of t? Well, we can say that this is equal to just 100 straight up. Or it's equal to 4 times h of 25 for t is greater than 25. And up to 32, but we don't have to write that since it's given in the problem, but might as well. And this is sort of a sloppy way of getting in terms of h of t. Writing this formula, they're probably okay with just giving 100 because it just levels out. But if you want to have it actually in terms of h, it's 4 times h of 25, since that's at the value which it stops.